What percentage of Teslas catch fire in 2023? Tesla autos are 48 times more likely to combust than combustion engines. 14.5% of Tesla fatalities involve fire or its synonyms. Because 7.7 million rows of big data from Cornell University suggests that the national average for vehicle fatalities involving fire is 0.3%. That means for every 10,000 deaths, only 30 will result in fire. Importantly, 14.5% represents roughly 145 out of 1,000 fatalities. Now imagine if the entire country was scaled to that level. The data is overwhelming. And in the video description below, you can get the links to the studies and the code so you can replicate the findings yourself. Just by liking this video, you might save a life. And if you share this video, not only will you definitely save a life, you will inform a Tesla driver. And if you think I'm wrong, well then prove it to me in the comments below. Hello world, my name is Data Mining Mike. I'm a data scientist and machine learning researcher. And as defensive drivers and informed consumers, we should mine into the data. All right, so here we are exploring the data in Jupyter Notebooks and Pi. Does the number of Tesla Motors deaths involving fire or its synonyms differ from the US population? Right here is another example of the dataset link. Here's another dataset link. We're gonna talk about this. The term null comes from the Latin word nullus, meaning none or zero. In essence, the null hypothesis represents the absence of the observed effect in the relationship. Therefore, the null hypothesis is there is no difference between the distributions of these two populations, between EV fires and combustion engine fires. But the alternative hypothesis is that one of these two populations differ, and that's what we're going to explore. And in this part of the code, I am importing all of the necessary libraries that I need. After I import the necessary libraries, the next thing I do is I import the data set. I'm importing the data set of the major Cornell University. This is a big data study. And the first thing I do is I pull up the head and I populate the head and we have the shape. So the shape is 7,728,394 instances of a death and 46 columns to be explored. If you want to be able to explore these columns more or this data study, there's going to be a link to that video description below. Here we are discovering the different data types. So there's a lot of variables here. Like they go into the weeds like for like humidity factors that cause accidents, but we aren't going to be going into that. What we are doing is we are going into the descriptions column. The descriptions column is the most important column because it's where people are describing the accident. So luckily Tesla has a descriptions column and Cornell with the big countrywide study does too. So this is what we're doing. In this specific cell, what we are doing is we're reducing the variables to the same variable. So we want severity and I want description. So the severity is going to equal whether or not it was a death. If the severity equals 4, then it was a death. So, or essentially a list of severity and descriptions, and I am passing that through this data frame right here, and I'm getting this out. So I have this new data frame of just severity and descriptions, and then the next thing I'm doing is I'm dropping all the empty rows. So after I drop all the empty rows, the resulting rows is 7,728,389 instances. So it was less than 1% sparse after we dropped all the missing off, after we dropped all the rows with the missing values. Next, we have to engineer this feature in order to isolate where the severity equals 4 because in the Cornell University, that represents death. So I do that, and this is the code right here. In this part of the code, we go into of the accidents, how many were fatal. So this is what I did, is I created a list of the target words: ignites, fire, combust, flames, burns, and explosions. Then I filter the data frame for severity 4, and this is the code which I use to filter the data frame, passing in severity 4 equals 1, and for the description column right next to it. And it goes through and it iterates through and it goes, it lowercases all of the strings, it counts them all and it joins them all, and it finds the target words. So the total number of the target words or rows containing the target words was 652. So that means of the 7 million something rows, 652 involve fire. So that means 0.003 or 0.3%. 0.3%. That is less than 1% of auto fatalities involve fire. Now exploring the Tesla dataset. When I import the Tesla dataset and I inspect the head of the Tesla dataset and I inspect the shape, drop all the empty columns, and these are all deaths. These are all deaths, so I don't need to filter them for finding a specific severity like I needed to with the countrywide dataset. So 296 deaths since inception. That's just the tip of the iceberg, all right? There's a lot of deaths that are going unreported. Now, I'm creating a word cloud of the frequency words used to describe the Tesla deaths. In this column, what I do is I have to strip all the empty white spaces in the column names because it was giving me hell. Natural language processing. Now creating a word cloud of frequently used words to describe Tesla deaths. In this cell, I import all the necessary libraries. I'm from NLTK, I'm getting the tokenize function, which I import tokenizer, and then I get this NLTK corpus of text of all the natural stop words, and I import the warnings and a counter, date time, and word cloud. So I import word cloud. And word cloud is really what we need. So I run this cell, and in this cell right here, this is all the code you're gonna need for creating word cloud. So if you want to create word clouds and have this script in your toolbox, you would be a much better data scientist for it. So in this portion of the cell, we are creating the word count variable by calling the Tesla.description, and then we combine all the video titles to one string by using the join function, calling the Tesla data frame and the description. Then we use the tokenize, and this is the important part where we tokenize. So I create different word tokens using the word tokenize function where I pass in the all titles. So I'm passing in all titles and I'm lowercasing them. So because we want to lowercase and we want to strip them for all the stop words. So we're removing all common stop words and common stop characters. And in this part of the code, we have the word cloud. The word cloud is the output with all of the words from the word description, from the description column that shows, here we have the output of the word cloud, which is the first indicator of all the unique words, such as burns, fire. To get the count of fire and its synonyms, in this part of the code, we test the two variables from Tesla deaths description and from the US dataset description. And we're gonna run them through Shapiro-Wilk. Shapiro-Wilk is gonna see if they are normal or Gaussian. So the Tesla is far from 1. This is negative 29 away from 1. So that's 29 zeros before the 2. So nowhere near parametric, so that's non-parametric, so it's gonna require non-parametric testing. The second one is 0 from US dataset, and that is an indicator that it is needing to run a Mann-Whitney U-test. And the Mann-Whitney U-test is going to compare the two differences between those two groups of data. And the output of the Mann-Whitney U-test is e to the negative 9.5, so way zeros out there. Based on the analysis of the data, the results of the Shapiro-Wilk test, the Mann-Whitney use test, and the Kruskal-Wallis test, we reject the null hypothesis in favor of the alternative. Therefore, there is evidence to suggest that a significant difference between the percentage of Tesla fires involving fire or related synonyms at 14% and the percentage of deaths in the US population of fire of incidents at 0.3%. Given the non-parametric behavior of both data sets, the tests were appropriate, yielding p-values less than an alpha level of 0.05. The conclusion aligns with the statistical findings, indicating that there is a notable difference between the two populations in terms of fatalities related to fire or similar terms. This highlights the importance of further investigation and attention to safety in the context of Teslas and similar electric vehicles. Based off these findings, the implication of replacing all combustion engines with electric vehicles would scale to the number of vehicle fires up exponentially. More data needs to be compiled to monitor this trend, and lastly, this finding can now be used as the vanguard for consumer awareness. Once again, my name is Data Mining Mike, and thank you for watching the video to the end. Be sure to like, subscribe, and smash that bell for more data-driven updates.